Solve system of linear equations in two variables. Student learning objectives. Solve systems of linear equations in two variables by the substitution method. Solve system of linear equations in two variables by the elimination method. So in this part, we're going to look at two other methods to solve a system of linear equations in two variables. And these methods are algebraic. So solve systems of linear equations in two variables by the substitution method. So we have two equations in the system here, and both equations are in two variables. So what we're going to do here for the substitution method, we're going to choose one of the equations and solve for one of the variables, for x or y. So you want to pick the equation that is easy to solve without getting fractions. So if, for example, we choose the first one, okay, x plus y equal to 5, and solve for y. Once we solve for y, we're going to substitute the y value that we get in the second equation for y. When we do that, we will have one equation and one variable. So for example, let's solve the first equation, x plus y equal to 5 for y. Y is equal to minus x plus 5. Now, we replace y in the second equation by minus x plus 5 because y is the same as minus x plus 5. So instead of writing it as y, we're going to write it as minus x plus 5 in the second equation here. So we have 3x minus 2 times minus x plus 5 is equal to negative 1. So what do we have here? We have one equation and one variable, and we know how to solve an equation in one variable. So we proceed by removing the parentheses first, plus 2x minus 10, so we distribute, is equal to negative 1. Combined let the like terms, which is 5x minus 10 is equal to negative 1. Add 10 to each side. So now we are solving for x. So we're adding 10 to each side will be plus 10 is 9. Divide each side by 5, 9 over 5. So the x coordinate of our solution is 9 over 5. So what we do next, we plug 9 over 5, x equal for 9 over 5 for x, in the equation that we solved for y. So we have y is equal to minus x plus 5, replacing y, x by 9 over 5, we have minus 9 over 5 plus 5. Now we solve for y. The denominator here is 1. To add, we need to have the same denominator. So we multiply the second fraction by 5 over 5 so that we have a denominator of 5. So this here is equal to, y is equal to minus 9 over 5 plus 25 over 5. So the sum here is equal to minus 9 plus 25 is 16 over 5. So y is 16 over 5. The solution to the system is an ordered pair. The x coordinate is 9 over 5. The y coordinate is 16 over 5. So this is what we got by solving. It has a unique solution, one intersection. So if we were to graph these lines, they intersect at this ordered pair in the rectangular coordinate system. So now we need to check. It's possible to make mistakes. So what we do when we check, we plug in the ordered pair 9/5, 16/5 to each of this equation in the system, and check if we get a true statement. So let's check for the first one here. So we have a check for x plus 5 is equal to 5. X plus y is equal to 5. So x plus y is equal to 5. X is 9/5. Y is 16/5 is equal to 5, question mark. They have the same denominator, 5. We add the numerators, is equal to 5, question mark. 25/5 is equal to 5, question mark. 25/5 is 5. 5 is equal to 5, correct. So this solution is a solution to the first equation. Now we need to check if it is a solution to the second equation. 3x minus 2y is equal to -1. So we have replace x by 9/5 and y by 16/5, question mark. X is 9/5, y is 16/5. Multiply. So the denominator is 1, the denominator is 1. So we multiply the numerators and then we multiply the denominators. 3 times 9 is 27. 1 times 5 is 5. Minus 2 times 16 is 32/5. This is equal to -1, question mark. 27, so they have the same denominator. So they keep the denominator, subtract the numerators. 27 minus 32 is equal to -1, question mark. 27 minus 32 is -5. -5/5 is equal to -1, question mark. -5/-5 is -1, equal to -1, correct. It's checked for the second equation. That means it gave us a true statement. Therefore, the solution that we found is correct. We didn't make a mistake. And this is our solution, 9/5, 16/5. So this is what it means solving by substitution method. You solve one of the equations in the system for one of the variables and replace the variables that we solved in the second equation. And then we get an equation in one variable, and then we can solve for that variable. Now, there is a second method. This is called the elimination method. So solve the system of linear equations by the elimination method. So what we are going to do here is we are going to add the two equations. So when we add the two equations, we are adding the corresponding the ones that have the x variable and the corresponding y variable, and then the constant terms. And then we will have one equation. So, but we need to, when we're adding, we want to make sure that one of the variables will cancel, so that we will be left with one equation and one variable. So if we are to add these equations that we are given as they are without changing anything, none of the variables will disappear. For example, if we add, we get minus 3x. And then 5y minus 9y is minus 4y. 10 plus 7 is 17. So we still have x and y. Our goal is to eliminate one of the variables when we're adding. So what do we need to do? We can add or subtract. We can also subtract. Even if we subtract, the one of the variables will not eliminate. So 3x minus 6x is 9x. 5y minus 9y is 14y. is equal to 3. 10 minus 7. Still, we didn't eliminate a variable. So what can we do to, we still are going to add the two equations, but we need to manipulate one of the equations by multiplying it by a constant so that the coefficients, one of the coefficients of the variables will be opposite of the other one. So for example, here we have the coefficient of the first equation, the coefficient of x is 3x. For the second equation, the coefficient of x is negative 6x. So if we multiply the first equation by 2, then the 3x becomes 6x. Now when it is 6x, we can add the first equation and the second equation. And 6x minus 6x is 0. So now we eliminated one of the variables this way. Okay, so these are the type of things that we are doing to eliminate. That's what we call it elimination method, because we're eliminating one of the variables by adding. It's called the elimination method. Another name to it is the addition method. We're eliminating a variable by adding the two equations in the system. So this is another name for it, addition method. Okay, so this is one way we eliminate x. If we decide to eliminate x, if we decide to eliminate y, then we need to multiply. We want the coefficients of y to be opposite signs. They have opposite numbers. So to make them opposite here, if we multiply equation 1 by 9 and equation 2 by 5, what do we get for the variable, the coefficient of y? In the first equation, it becomes 45. In the second equation, it becomes minus 45. So now we have 45y minus 45y. It cancels the y variable. And now we are only left with the variable x, and we can solve for x. Once we solve for x, we can back substitute in the original equation for x and solve for y. Okay, so now we have different choices that we can eliminate. Okay, so let's go ahead and solve this equation by the elimination method, and we decide to eliminate x, the variable x. And so the first thing is call the first equation 1, the second one equation 2. So what we're going to do here, we're going to multiply equation 1 by 2, and then we're going to add it to equation 2. So these are the notations that we're going to use. So 2 times 3x plus 5y is equal to 10. And then we have minus 6x minus 9y. Let's multiply this. We are multiplying equation 1 here. So this gives us 6x. So we distribute the 2. Plus 10y is equal to 20. And then the second equation, we're going to add to it minus 6x minus 9y is equal to 7. So we're adding this 2. So what do we have? 6x minus 6x is 0. We're adding the 2. So this is 0. 10y minus 9y is y. 20 plus 7 is 27. So y is 27. So let's call this equation 3. So we then note it here, back substitute equation 3 into, you can choose equation 1 or 2. So let's choose equation, let's do equation 2. Or equation 1. Smaller numbers. We have 27 is a large number. So equation 2. It doesn't matter as long as we use a calculator. Okay, so equation 1. So 3x plus 5y is equal to 10. 3x plus 5 times 27 is equal to 10. 3x is equal to 10 minus 5 times 7 is 35. 5 carry over 3, 10. 5 times 2 is 10. 10 plus 3 is 13. So 3x is equal to minus 125. X is equal to 125 divided by 3. What is our answer? 125 is our solution. Solution 125 over 3, comma 27. Is this correct? Let's check our answer. So always check your answer. So let's check by plugging it into the first equation. 3x plus 5y is equal to 10. So 3 times 125 over 3, 3 times x plus 5 times 27 is equal to 10, question mark. The 3 cancel, 125 plus 100. This is negative 125, negative. So this is negative, negative, plus 135 is equal to 10, question mark. This is 10 is equal to 10, correct. So for the first equation, it checked. Let's check for the second equation. We have the second equation, minus 6x minus 9y is equal to 7. So plug in minus 6 times x is negative 125 over 3 minus 9 times 27 is equal to 7. Let's check. By 3, 1. By 3, negative 2. Negative 125 times negative 2 is 250. 250 minus 9 times 27 is 243. So is equal to 7, question mark. So this difference here is 7. So it's checked. So this is a solution. So always check. It's very easy to make mistakes because the calculation could be, when you do calculations, it's very easy to make mistakes. So always check your answer. You either make a mistake in your work, or you can also make a mistake in your checking. So always go back and check.